Before we introduce the panelists, want to give you an overview of what the AI ML space looks like, just to sort of give you a base knowledge, a base knowledge here for the upcoming questions from our great panelists today. So the emerging trends within AI-driven automation reflect significant shifts of players and actions within the AI sphere. And this reveals the reconfiguration of ideas, interest, influence, and investments within the overall AI domain. For example, enterprises are starting to understand the results of the evolving AI-driven automation ecosystem far beyond what was, narrowly known as quote unquote artificial intelligence. There are many other tools behind what may be defined as artificial intelligence that can be used by the enterprise today. And this is also driving other industries, economies, commerce, but also entities like education and government. And overall, the connection between enterprises and automation is somewhat complicated and sometimes indirect. The force and pace of AI-driven automation is expected to change within the coming years and will present each enterprise's challenges and opportunities for some of the products, services, processes, operations, and overall supply chains. So with that said, I want to introduce our panelists for today that will be speaking about some of these topics. The first is Raviraj Jain. Raviraj is from ITT Bombay and has gotten his MBA from Harvard University. He was the co-founder of Hello Intern and Book My Cab, both very successful Indian startups. He also worked in product management at LinkedIn before transitioning to venture, where he's worked at Lightspeed since 2017 as a general partner. And we all know how big Lightspeed is. One of our investments is actually led by Lightspeed in multiple rounds, Rubrik, and we've spoken about them multiple times. And lastly, we have the pleasure of hosting Andy Manoske, sorry if I butchered that, with his passion for building next generation infrastructure and technology to power and protect the digital migration of our world. Andy has also led multiple enterprise technology products from pre-launch to industry leadership and hundreds of millions of dollars in annual revenue and investments. So with that, I'm going to pass it back to Catherine, who will host our chat today.
Thank you very much. So we're a little bit early, so we'll have a few panelists joining us and then waiting for a few more. So also, unfortunately, Ken is unable to make the talk today due to sickness last minute. So we have Hyuk-Jeen also joining us today. Jeen, would you like to give everybody a little overview of yourself and your fund?
Hello, everyone. My name is Hyuk-Jeen Suh, a general partner at a new fund called Skyriver Ventures, which is a deep tech focused cross-border fund based in Boston, Massachusetts. We do early stage pre-seed to Series A investments and try to help early stage startup companies build collaborations with multinational corporations. So prior to Skyriver Ventures, I was the US East Coast head of Samsung Ventures, investing across a broad array of industries. Nice to meet you guys.
Okay, great. So we're waiting for the two other panelists to join us here. I'd love to kind of, just ask a few questions, actually, if you don't mind. So, we are very much deep tech focused and love to learn more about what's going on in this space. There's a lot of news that's coming out in deepfake. We had a panel on, how AI is really impacting that world. And we posed a similar question earlier. What do you see are some changes, given that this industry has grown quite a bit? Has there been policy changes that really, curtailed this area? What do you think are some challenges, we're looking at when it comes to deep tech developments?
Deepfake is continuing to grow, and I think there are always pros and cons to all of these types of technology development, right? On the positive side, it can be used, as another form of, creating synthetic data to help people, create new types of entertainment and so on, which, we talked about earlier today. But I think also there are challenges from a security perspective. In order to counter that, there hasn't been, from what I know, major changes in policies, but there are now, especially in the government side, entities trying to figure out to validate the deep fakes and so on. And I think that's going to be very critical. It's going to be a growing sector to a lot of this deep fake applications that are starting to pop up. But I think a lot of the similar technology can be used in other areas to really benefit mankind and applications, right? All of that computer vision technology can be used in areas of trucking and so on, which you just talked about, for pedestrian crossing applications and simulations, and trying to become more human-like in these types of interactions. And so I think the deep fake is not necessarily bad, but it can be used in that way. And so there are interests to counter that.
Great, thank you. So let's see if our panelist has joined us here. Yeah, a little bit of overview here. I know we mentioned a little bit about what our focus has been when it comes to, AI, ML, and deep tech. Some of our best investors within our network have spent a lot of time looking at, somewhat, we call it moonshots, areas that are just really, whole next level. I mean, we've invested in space tech, we invested in, things that are basically in the realm of quantum physics, right? But these are more, I think, for people who has like a very long-term investment philosophy, right? 10-year, probably 20-year timelines we're looking at. What do you think distinguishes the investors that are looking at deep tech for a more short-term period? What are other areas that you think they should take a look versus someone who has more of a longer-term, exit strategy? What do you think the areas that they should be looking at?
So I think, for instance, AI is just one part of deep tech. I mean, deep tech is pretty broad, right? It's kind of a horizontal platform, if you want to call it that, when it comes to, biotech, new novel materials and all of that, space tech, quantum technology. And some of these things do have long-term, will take a while to actually grow that to a commercial application. But there are more immediate applications. So even if you're doing, for instance, in the area of quantum technology or quantum computing, there are more immediate applications, for instance, in terms of drug discovery, computational chemistry, even logistics optimization and financial modeling, quantum cryptography. All of these things can be applied today, even like weather forecasting. And so it's not necessarily deep tech, not all of them are, even the quantum area, not all of them are long-term. Some of them are. And others are more immediate, right? We're looking at companies in the imaging space using quantum technology. So those are more immediate, but there are other things like in the area of, that involves entanglement, quantum entanglement, things like that, that might take a long time. But, there are applications that are more short-term as well. I think the way the investors behave will depend on the structure of the fund and the duration of the fund, meaning some funds in the deep tech space tend to be longer duration, maybe 15 years, 18 years in duration. So they have a much larger, a longer horizon, whereas other quantum funds might be a traditional 10-year fund with a more, a shorter term time frames. I think it depends on the structure of the fund also.
All right, we have the whole panel here now. Thank you, everyone. So as we have started with a little intro for each one of you, I know Ravi and Andy just joined us. By the way, happy birthday, Andy. I have no idea, but today's your birthday and still made it. You're the champ. Thank you so much. Great. So let's get started with this panel. I'll post a question for everyone here. Do you think the progression of AI technology will be primarily driven by private companies to generate a profit or by academics with the intention of innovating our world for a better future? Perhaps both. I'll leave it up to y'all. Actually, I'm looking at you with a smile, so I'll ask you first.
Well, I think it's a mix, but really a lot of the cutting edge stuff in AI is happening in academia. For instance, some of the big challenges we have, a lot of the AI stuff, for instance, is built, but it's actually a quite fragile system, right? You could take an image of a panda and just, add a little bit of noise to it, and you can turn and look at, and the computer will recognize it as an orangutan, for instance. And so these AI systems are quite fragile. And so there has to be next generation of technology, for instance, an AI that would make it far more robust. And so a lot of that is happening in academia. I think when it comes to big corporations like Google's and the Facebooks of the world, they are trying to do this at scale. And I think that's where they come into play, although they are doing a lot of things that are pretty cutting edge, but really truly disruptive AI stuff, I think, is happening in academia. For instance, instead of going from traditional neural networks, there are topics like capsule networks and this thing called GLOM networks that are now popping up. And we can talk about that, later on in more detail if needed. But those things are happening, and that's all happening in the academia. But to get to scale, I think that's where the corporations are going to come into play.
Yeah, I tend to agree. I think we have seen, and as we scout for a lot of opportunities in AI, I think a couple of places where we've seen kind of like
double clicking on what Hugh is saying is like, one is, research groups at great universities tend to come up with new techniques, like a company like Snorkel we invested in, which is building a new weak labeling platform to enable mass labeling, I think leading to like much bigger things. So I think that's one angle. And the other is companies that are at the cutting edge, like Netflixes of the world and Facebooks of the world. And now they're dealing with the kind of data sets that nobody else has seen before, right? And I think any incremental improvement in how they derive insights from that data can mean hundreds of millions of dollars for revenue for them. So they are able to dedicate, a lot of really high quality researchers and resources to that. And that's why you're seeing a lot of sort of like uptick and like new technologies being invented there. But just to the other point around what you said, Catherine, around the government, I think there is a lot of stuff happening there too. Although I've seen governments and Fed being a consumer of these technologies right now versus creator, but that can certainly change as we are seeing a lot of focus going in that direction and billions of dollars, being spent there.
And it's not just AI too, really any kind of like deep tech that is the beneficiary of advanced mathematics or advanced basic science is ultimately the beneficiary of like large investment by the US federal government and her allies in terms of like NSF grants and other things. Really concrete examples of this include, for example, here at Hashi Corp Vault has a feature in Vault Enterprise called format preserving encryption. The algorithm that was used for that is a direct consequence of academia that had generated something called AES FF3-1, which is a format preserving encryption algorithm that was generated largely by government investment as well as research from academia within the US, Western Europe, and in Canada. So there is kind of this, whether we're talking about cryptography, whether we're talking about AI ML, whether we're talking about like advanced computing, grid computing, et cetera, high performance computing, there is kind of this long running trend throughout the entire like 50+ year history of Silicon Valley of significant investment in basic science as well as in advanced mathematics that leads to advancements in academia that the entrepreneurial community, both venture capitalists as well as companies, take advantage of to be able to utilize and ultimately seek economic problems to marry that combination of advanced mathematics and advanced science with a solution that provides economic value for the market.
Great, thanks everyone. So then we'll go into the next question. The bottleneck of AI today is algorithm training. Do you foresee a solution for that challenge? Hyuk-Jeen, would you like to take this one?
Yeah, so there are different types of bottlenecks when it comes to AI and training. But as I mentioned, one of the things we have problems about is in the area of having these fragile. And so new types of technology is dealing with that, right? So traditional neural networks have this issue of having what we call the Picasso problem, where if you have a face and two eyes, nose, and a mouth, the placement of the eyes relative to the nose is important to recognize that it's actually a normal human face. But some of these neural networks that we have are not capable exactly of doing that. If I misplace the eye, switch the eye, one of the eye and the nose, it would have these issues. And so these new types of technology, as I mentioned, like GLOM technology that's coming out, has a spatial relevance and is able to take that, understand relatively where things should be and attribute certain features to understand at a high level what's happening. And when it comes to things like AI training, there are now new technologies that are being used to kind of address that. For instance, the concept of transfer learning, where you may take an AI that has learned something within a specific domain, let's say dents in cars, for insurance applications, and then taking that knowledge of how dents are made and what they look like, and then take that exact knowledge and apply it to where there's not a lot of data, let's say regarding dents in aircrafts. And so even though there's a small data set that they can still apply that. There are other types of technology, for instance, when you apply supervised learning where humans, where there's a small data set, can actually tell the AI and train it to handle those types of bottleneck limitations. And then when there are small sets of data that, where it's hard to train an AI, that now there are technologies that are creating what we call synthetic data. So instead of having to, for instance, drive a truck down the road on a sunny day, and then do it on a rainy day and a snowy day and a cloudy day, that the synthetic data can actually create these scenarios that allows to drive down the path in one day and then be able to create those simulations and be fully tagged so that the AI can learn quickly. So a lot of different ways of handling that. And there are new technologies that are actually just targeting specifically, not about having to see a million cat photos, but can we do it now with big data, with small data sets? So a lot of interesting stuff that's happening there.
Yeah, and I think I was just alluding to like this whole thing around training data, right? I think one of the biggest bottlenecks in AI is labeling and annotation of large set of data, right? And I think we've seen large companies being created where people are spending hours and hours just tagging that data, right? Like there was this one stat when I read a while back, which is like for a mile of self-driving car, a drive, like for a mile, they actually take 800 man hours to tag everything for the first time, right? So it takes a long time, and that tends to be the bottleneck. But then there are other techniques, just like you said, like, just like synthetic data, but also like things like Snorkel, right? Where they're saying, look, you can think of high-level labeling functions that can label data en masse, right? You don't have to hand label everything. Now, suddenly you can accelerate the rate at which you label and annotate data, and the time it takes to build the model and get it deployed actually shrinks by like a small fraction of the percentage, right? So I think there are many different approaches here that people are taking, and we are already seeing the benefits of that in terms of faster model deployment, and even though as they get more and more sophisticated with time.
There's also a really significant amount of challenge that comes not necessarily from like the mathematics or the inherent algorithms inherent to AI or even the models themselves, but also the computing power necessary to be able to resource and analyze all of this. I mean, to Raj's point, when we look at sort of how you actually gather that much data and analyze it, one of the reasons why there's so many mechanical Turk processes or other people that are kind of injecting themselves into the process of trying to manually tag it themselves is because the computing cost to store, resource, and then ultimately automate the process of analyzing that data is very large. So one of the things that we have to worry about as a community is not just how do we improve like the basic mathematics that power AI or the modeling that powers AI, but also how do we improve the infrastructure that allows us to be handle similar types of computational problems like AI at the exabyte and soon zettabyte level scale of computing that we're entering into over the course of this decade.
If I can just add one more thing to that. So if you look at the data, we have tremendous amount of data on certain areas and not on others, right? Tons of photos of cats, a lot of miles. And the problem is that AI, we train this AI on all of that data. But once it's seen 1 million photos, it doesn't need to see 10 million photos of a cat. And so this whole, you have to have, there's a lot of redundancies in that. But what's important to train the AI are the edge cases. And so now, in order to optimize the AI training, the time to do it is to now find those edge cases and just filter out 95% of the other data you have that's really not needed because it's actually redundant. And so there are companies now targeting that and doing these edge cases. And in order to actually accelerate some of the stuff, they do things that we'll call federated learning and so on to actually continue to accelerate the training of the AI.
Great, thank you. Thank you, guys. So our next question is, what are some, can you tell us more about the movement from traditional world infrastructure to the modern deep tech infrastructure? Maybe Andy, you can take on this one.
Yeah, absolutely. And this is kind of what we were just talking about with AI, where we're facing computationally intractable problems. When I say computationally intractable, it's just a very highfalutin way of saying really hard computational problems that require lots of space, lots of energy, and then lots of, like network traffic. I think folks that have kind of come into distributed computing, blockchain, or kind of like Bitcoin backgrounds start to appreciate this. But in reality, when we look at the kind of problems that AI or other elements of deep tech have to face, these are inherently very computationally difficult problems, many of whom have solutions that are ultimately a divide and conquer approach. So we need lots of computing power, we need lots of storage space, and we need lots of networking power to be able to associate with all this. One significant challenge that we've seen here at Hashi Corp, but is very well played across sort of the development of multi-cloud infrastructure and computing as a whole, is the fact that computing is moving from a world of static infrastructure to dynamic infrastructure. What I mean by that is that when we typically think of like enterprise computing or advanced computing in the past, we think of a big data center with lots of big storage racks and lots of big servers. And then we federate all these data centers together, and then we go to town, divide and conquer the problem. In reality, that's just economically infeasible for a number of different reasons. And so we have different like places where I might push compute like a cloud, or I might have my own private cloud, or I might, for example, have lots of spare resources that I might allocate time and computing power and networking power and storage power to. This is where things like Kubernetes and other types of like containerization solutions come from, where I can better resource what kind of like available computing power I have to kind of divide and conquer on a big problem. So when we look at deep tech as a whole, which can be, as a number of different challenges spreading across a number of different industries, but it can all be thought of as really computationally difficult challenges with big dollar amounts tied to them from an economic point of view. The world needs to move really well to this model of embracing and squeezing out as much computing, networking, and storage resources as possible. And to do that requires us embracing ephemeral computing and really grabbing computing power and storage and networking resources from wherever they are and they exist in the world to collaborate together across a global plane to solve problems. And that yields a lot of new technology, both from open source technology, like closed source technology, enterprise tech, et cetera. So to power deep tech requires a whole new generation of software. And really, it's kind of like the next iteration of software eating the world.
Thank you very much. Our next question is for Ravi. So given that you are looking at various deep tech companies and from earlier stage, right? We look at some companies that are probably more later stage. How do you see this trend, of VCs now jumping into more earlier deep tech companies? Do you see companies are just taking a much bigger, taking on harder problems to solve, or areas of, for example, AI chip making, right? We're seeing a huge shortage in this industry. How is that impacted your, investing strategies?
Yeah, I think, like there are always investors who are focused on early stage and late stage, right? That hasn't changed, right? What has changed in the last few years is that there has been a lot more capital chasing at the growth stages than there was available before, right? And that's great for founders, right? Because now you can take bigger bets and you don't have to necessarily feel like you need to, like you don't have to be constrained by the capital availability if the idea is bold enough, right? And this is great. Like I think a part of us, like bunch of us, when investors always talk about, how this is like creating a dynamic where the startups are getting overvalued. I actually think that's great for deep tech because you need to hire really high quality talents early on, and you can't really do that. So your ability to raise more capital enables you to build big businesses, right? And we've seen some of those in the conferences where like companies in the self-driving car space or autonomous trucking space where capital was not available before, but it is now. And that gives us more confidence as an early stage investor, right? That we can back bold entrepreneurs who are thinking about changing the world. And I think, I've been fortunate to work with several of those, right? Like there's Dexterity, which is building the most advanced autonomous pick and place, robots for warehouses, or Reliable Robotics, which is making planes autonomous, right? Or Aurora, which is kind of
just curious. I mean, we definitely looked at Dexterity and met some of their early engineers. When they first told us about this company, I thought, okay, they're picking up res. Interesting. This is definitely, very deep tech and about the utility of it, right? So love to just get it from an investor's point of view, right? How do we sort of see companies like Dexterity really transform the way, we live our lives?
I think this is the good thing about deep tech companies is like, if they work, there's no limit to how big the market opportunity is, right? Like if you have to just give you a stat, the total amount of warehouses under construction in 2013 in the US was 25 million square feet. That is 275 million square feet now. So it's grown 11x, right? Like the number of Amazon packages we receive on a monthly basis have certainly increased several fold. And there's just no way on earth that these organizations can actually fulfill those demand coming from consumers to actually pick, place, and pack these boxes. And this has always been a very hard problem because it involves robots working in a semi-structured or unstructured environment, right? And I think with the advancement of computer vision and so like the hardware getting cheaper and the network bandwidth improving, it actually has created an opportunity when you can actually have robots that work in warehouses at the same rate as humans and actually complement them and enable the entire supply chain, right? And I think that to me is a massive opportunity. I mean, I personally believe that in the next 10 to 20 years, we'll have more than 100 million robots in the world working on really powerful and important tasks, right? And I think this is just the beginning.
Gotcha, great. And then next we have another question for, so India is home for some of the fastest growing startups in the world. 2021 has been a record-breaking year for Indian venture capital investment. As someone who has extensive experience in the Indian startup ecosystem, what are some lessons that the US-based founders and investors can learn from India's rapid growth, especially in the AI ML space?
Yeah, I think that's a great question. Just full disclosure, I haven't really invested in Indian startups in the last several years, but Lightspeed has a presence in India, and we are seeing just phenomenal growth in the startup ecosystem there. It's largely driven by, honestly, two things. One is on the consumer side, just the demand from consumers is really coming up because people have access to internet. It's the cheapest internet in the world. But the second thing is the availability of technical talent. That is huge, right? And that makes a huge difference. Like anyone who's running a startup in the US would realize that hiring good quality engineers is not only expensive, it's almost impossible, right? Doing it at scale. So I think that's the benefit that India has. However, I would say like the biggest markets or the customers are all here in the US or Europe. And I think that's the disadvantage Indian startups have, is that they're not close to their customers. And therefore they really need to build successful Indian companies that have succeeded or to scale to billions of dollars, all have a big presence in the Western world to be able to be close to customers. But yeah, I think the funding situation is strong. I've also started seeing that more and more companies are starting to build a presence in India to take advantage of the high quality and relatively cheap, not so cheap anymore, but certainly cheaper than Silicon Valley, technical.
Okay, great. And then for Andy, in terms of your work in the Hashi Corp and also DevOps world, what do you see are some of the changes that has happened? We see some newcomers now coming to your world. Can you just give us an overview of what's happening in the DevOps world? How does that change, and what's the implication of changes in DevOps that might spill over to other industries?
The short answer there is that we're seeing a much larger, much more democratic, much more equitable distribution of software engineering talent that is entering into this generation of software engineers, into developers. So the consequence of that is that the tools that they demand, the experiences they demand, the infrastructure that they require is going to look a little bit different than the infrastructure that, for example, I saw and got used to when I got my bachelor's in CS 10 years ago. So the static to dynamic world is kind of the forcing function of what we see a lot in terms of the computing needs and the challenges they're trying to solve. But when we talk about what developers want and ultimately what DevOps needs, what we're seeing is more of a progression towards how do I think less of that infrastructure as a whole? How do I think less of what is my operating system that I'm running on? What is the network that I'm operating on? How do I write to a file system, et cetera? These are problems that are kind of ancillary problems that hopefully are better solved by whatever framework you're using, whatever programming language you're using, whatever libraries you're using. And so there's this gradual movement to what we call infrastructure as code, where this idea is that I would like to describe to a program that would abstract the development of that infrastructure, something like Terraform, for example, that would deploy that infrastructure for me, figure out how to ultimately connect all the bits together. And then I can focus on the heavy lifting associated with programming and building new apps, new technology that powers deep tech or whatever kinds of challenges that you ultimately want to go solve. That's great. But that means that as we see this new generation come into play, they have different languages they use different frameworks. They see different programming paradigms differently than the previous generation did. And as a consequence, either new tools need to adapt to better suit this style of infrastructure as code, or completely new solutions need to be unveiled to change how we think about delivering infrastructure in a way that developers don't need to.
All right, so we're gonna do a roll of fire questions, short answers here only. So what do you think, Hyuk-Jeen, are some misconceptions about AI and deep tech?
I would say one of the big misconceptions that deep tech also requires high capital intensive kind of investments. And I don't think that is necessarily true. There are a lot of companies that don't require that or capital light that you can invest in.
Great. And for maybe we can take this one for Ravi. How would you evaluate a deep tech company versus a consumer?
I'm not a consumer investor, but I would say in deep tech, it all boils down to the founder's background, right? I think you need to have really deep understanding of the space that you're operating in. You can't really start a company without that. But I think the other part is, and which is very important, and is an important lens that I take, you can't just be a technical person and build a company, right? You have to be very problem centric. So every founder that we meet in deep tech not only has to have a really like very deep understanding of the space, but also clearly understand the problem that they are trying to solve. And I think this is much less common than you would think.
Great. Andy, not trying to be, but I don't know why I'm picking on you this one. So US versus Asia, where do you think is the center of innovation in deep tech, given that you're Hapa?
Excellent, fantastic. Well, just like my ethnic combination all over. I think the reality is that deep tech is powered by basic science and advanced mathematics. This is not the sole property of the United States government or her allies. It is the property of the human race. And so you see a lot of innovation in this coming, not just from the US, but for example, a lot of really interesting grid computing technology came out of China, and being able to route and efficiently handle large scales of traffic across, very unreliable internet with, that's like twice the distance from the US West Coast to the US East Coast, and be able to handle consensus across that. So it's really less a function of, it's one geography or the other. It's who has the best basic science and advanced mathematics in the areas pertinent to this, like the styles of deep tech that you want to develop.
All right, next. What is the role of government in mitigating harms of artificial intelligence and establishing safeguards?
Yeah, I think there is an important role, right? And we are seeing that with what government did with privacy, with GDPR and other things. I think the same thing has to happen on the AI front, and even more proactively, right? Because the risks here are much. I do see some movement there, but I think we're still ways away from coming up with real regulations. There are companies like Fiddler Labs, on the explainability side, and governments are asking companies to make sure that the algorithms are not biased, right? And I think we will see more regulations coming in, and it's very important to do that, not just at the national level, but at a global level.
And then we have a question on, so, as a company, because we're very much focused on international cross-border investing, but also developing fundamental research, what do you think is the impact of quantum computing on AI ML? How has that really played out in your respective businesses or in your venture strategy?
So in my area, in AI ML, so to step back, I know we only have a very short period of time. The short answer with quantum computing is that quantum computing enables a style of computing that is massively parallelizable. It's really hard to read. The computers kind of suck, but it's massively parallelizable. And if you know what you're doing in math, you can exploit some cool things in probability theory to do things that were otherwise impossible to do with classical computers. That all being said, when quantum computers work, they generate lots of random information because of the combination of the Heisenberg uncertainty principle and the observer problem. Combined together, it creates a lot of entropy, and entropy is extraordinarily valuable to AI and ML. It's great for modeling. It's great for doing things like random walks down Wall Street to be able to analyze different types of market situations, et cetera. So randomness, which we can resource today, is very valuable, and it's basically the waste of quantum computing that we can use today to power lots of really good AI operations. But in cryptography, the other area that I'm in, it's actually a significant threat, and it's guiding how we think about building new types of encryption algorithms and ways to deal with this. Because the reality is, in probably a decade, quantum computing is ultimately going to yield a situation where half of the internet's communication traffic is vulnerable to governments that have strong enough quantum computers and good enough mathematicians.
Hyuk-Jeen and Raviraj, would you like to comment on this?
I think, look, in the end, I think I agree with Andy. We are just still early days for quantum computing to be, plausible and scalable. So we still have to see that, right? My personal belief is that, the moment when quantum computers become real and scalable, I think this is massively expedite the evolution of AI in the world, right? And I think that because we are compute bound in some sense in many of the current AI approaches, so I think that's going to happen. I just am not sure if quantum computing will come first and become more, easily available, or AI will probably evolve in a way that we would not need that much compute or data. So we really don't know. But I think in my mind, in the next 5 years, AI will become everywhere, right? In many shapes and forms. I can't say the same about quantum computing. So we'll still have to see how it goes.
Great. And then we see an anonymous question here from an anonymous attendee. What's the contrarian position that each of you hold about either in favor or against adoption of different applications in deep tech?
I think I'll start with and this may not be answering the exact question, but I think my controversial opinion is that AI is heavily underfunded. I think we are all not truly understanding the impact that this can have in the next 10 to 15 year time frame. So the amount of funding going to AI is still a very small portion of what there should be. I think that if you look at human productivity, there are lots of different things that happened, like agriculture improved human productivity massively, industrial revolution did that. And I think AI is the next one which can compete to shift in productivity equivalent to industrial revolution or more, right? And if that is the kind of change or impact that we are talking about, I think the amount of funding that's going in and resources, not just from like investors, by the way, from governments, from universities, is actually very tiny. So that's kind of like my contrarian view, that we will all be spending like 10, 20, 30x of what we are in like a very short time frame.
On my end, I think when we talk about deep tech, an area that's like endemic to all of deep tech is distributed computing. And I think in Silicon Valley, at least, there's a lot of hype when it comes to distributed computing around blockchain and sort of like blockchain technologies to ensure secure distributed computing. That's very interesting because as a trained cryptographer and someone that works in distributed computing, most of my field vehemently disagrees that this is the right way to go. And I guess the best way to put it is that whereas there's kind of this energy in Silicon Valley around blockchain technology as like the right solution to every kind of distributed computing problem, in the academic community, as well as when you look at like high performance computing and even in the US federal government and other areas like that, we don't look at it that way. It's kind of like the difference between like if blockchains were biplanes, like really powerful high performance biplanes, and this is like 1939, we are focused on jets. Like there are other types of technologies that exist around creating secure distributed consensus, like secure multi-party computation, homomorphic encryption, powering different types of like secure networks, et cetera, where they're less exciting and they're less kind of cool, but they are likely the way that we are going to go, at least in terms of solving large, secure distributed computing problems. And I'm excited to see sort of how that kind of battle plays out, but ultimately it's something that's kind of at least controversial given sort of where the rest of the valley is.
Andy kind of touched on what I was going to say as well, but as the technology gets more and more complex, and as we have all this data that's generated and so on, the question is, how do we continue to develop the deep tech? In order to do that, you have to be able to share the data across multiple parties and so on. And it's very difficult due to privacy issues and GDPR and all these other things. And so a lot of people are pointing towards, let's have full transparency using blockchain and sharing so we know who's accessing what. But I also believe that there are certain scenarios where that is not appropriate, right? To have Novartis and Pfizer share data, patient data, whatever it might be, to develop next generation COVID-19 vaccine or whatever it might be, is very tough. They don't want to share that information. For Samsung to share its customer database with Apple, right, to have proper bioauthentication. These are very difficult things to do. And that's where things like, I think, multi-party computation, MPC, will become really important. And so it's not about just purely having full, everything data sharing in the blockchain, but this area of having encrypted data remain encrypted and being able to actually share, I guess the results rather than sharing the data is going to be key. And so I think in the future that will become more relevant.
Great, thanks everyone. And then we have one, I guess, question that may take a while to answer. What do you think are some of the bottlenecks right now in terms of, investing in companies that may, take some time to prove itself, right? Like we've seen some of the acquisitions lately in the AI chip making business, right? Once it's actually developed, then it's a multi-billion valuation already. So as an investor in looking at these type of companies, I mean, me, myself, as an example, right? We look at a business very early on. Typically we're investing growth to late stage, but, for the very exciting deep tech related, in companies, we are looking early stage as well. So as an investor looking at this type of business, what are some key indicators of potential success, even at the very early stages?
So I think, the difference between deep tech and other types of traditional technologies, you have to go through this, they call it design, build, test, and then kind of redo the whole thing, right? Loop back, right? And in traditional technologies and traditional marketplaces, you might have a marginal improvement, but in deep tech, we are truly trying to solve something that has 10 or 100x improvement in what's being done today. And so unlike traditional technologies, deep tech, they need to mitigate the technology, the problem upfront. And when you have a company that is targeting really challenging problems, they're able to show how to mitigate these issues and resolve those upfront, then I think there's a huge potential for the company to really grow. Now, the problem with deep tech, a lot of people say, is that you need to put a lot of capital in. And in some ways, it's actually quite true. Early stage, deep tech companies do require more capital intensive investments. But over the life of the fund or life of the company itself, over a 9-10 year typical lifespan of a company, deep tech companies actually require less funding than traditional SaaS digital companies because, once the technology has been, kind of proven, right, and the product has been made, then it's just pure kind of revenue generation over time, and you can limit the amount of capital that's required. Whereas in the digital space or in the SaaS space, there's a huge amount of cost of acquisition and growth, and to actually execute on the services that you're providing, whether it's Uber or WeWork and others, to deploy that is massive. So the cost goes up, and the deployment of capital that's needed in the later stages of SaaS companies and digital companies is much more than deep tech. And so when you look at companies that investors are investing in deep tech companies, they invest more in early stage, which means they actually have perhaps a larger equity stake in that company, which then provides them a higher opportunity of a nicer return at the end. Even though deep tech companies may not be valued at the SaaS company levels, but I think in terms of the IRR and returns, they can do quite nicely.
Yeah, and I think I agree with Hyuk-Jeen, what he's saying. I think the other way to think about just for early stage, right? Like I think there are 4 risks we take as investors, right? There's technology risk, there's product risk, there's market risk, and there's execution risk, right? At the early stage, you can't really you use founders as a proxy for execution risk, right? Like you think if they're high quality founders. I think in deep tech, what you don't want to take too much is the market risk, right? You need to make sure that the technology making it work is hard, but if it does work, it's a pretty massive market opportunity, right? Because if that's not the case, you can build a business pretty at low cost, and then hence you can potentially target smaller markets. Because there's so much upfront investment in deep tech, I think the market risk is something you need to be very careful of and validate at the early stage. So that's one. The second thing is, I would say it's really important, and I said that before, is product/problem centricity of the team. I think I cannot emphasize this enough. There are so many strong technical teams who are A, solving the wrong problem, or B, really are building products in vacuum. And I think those two things have to be so when you are evaluating an early stage founder in deep tech, truly understand, well, they may have PhD from MIT, and that's great, right? You need that, but that may not be sufficient, right? You really need to understand if they've spent time talking to 20, 30, 50, 100 customers and validating whether their need is something that what they're solving for has a big need and there's budget behind it. Right. I think those are some of the things I would look at. And then finally, I think interestingly, it's important to also make sure this is a space where you can get potential follow-on financing. It's not that big a deal right now, given so much capital, but because the time to actually drive significant revenue is much longer in the early days, I think making sure that there are enough investors who you think can get along with you, and in fact, even partnering with them early on so that you have multiple deep pockets behind the company also optimizes the potential for success of the company long term.
Thanks everyone for your insights. Is there any last minute words you have for the panel before we let you go? I know you're all very busy people, so any last comments?
If I can just say one thing, I think traditionally with deep tech and deep tech funds, they actually tend to be smaller than traditional generalist VC funds. Over from, I think, 2010 to 2020, the average fundraise for deep tech, was around 96 million. And for a general fund, it was 106 million. If you now add in the growth stage funds in there, deep tech funds typically end up being roughly about 105-6 million in terms of fundraise they've done. But for general funds, it goes up to 150 million. And so there's a little bit of a paradox here that people say deep tech is more capital intensive, yet the funds are smaller. So where does the remaining amount of capital come into play? And it's from 2 sources, I believe. One is in terms of a variety of government grants that are needed to actually subsidize and help these companies at the earliest stages. And then 2, there's a huge need and demand from large corporations to continue to develop and will go along with these companies. So in the deep tech space, unlike others, there's a huge interest and huge need for large corporations and startup companies to partner in order for the deep tech company to become fully commercialized. And so I think that's going to be really critical moving forward.
Well, with that, thanks everyone for participating in our AI ML Deep Tech panel. I really learned a lot here.